Go. All right, good afternoon slash evening, everyone. Welcome to the, what is this?
This is the
Ninth. It's the ninth, the ninth workshop out of the 12 that we have. Time does fly, and I definitely recognize you guys a lot from the previous workshops. And if this is your first time attending a CPP Hyperloop workshop, welcome. We're really glad to have you here. So today's soldering, which is by far our biggest workshop of the semester, where we teach you guys how to solder. You guys solder a project kit together. How many of you guys have been here last year when we did our first ever soldering workshop? Raise your hand. One person, two person, three person. Some of you guys. So for most of you guys, this is your absolute first time, and I am so happy you guys chose to come here today and learn how to solder because we have some fun activities planned for you. I don't know if you guys saw the the fully constructed version that was in the front, but that's what you guys are constructing. So I don't know if Sam can bring it here. Basically, what we're making is a binary counter / 7-segment decoder that allows you to flick the switch. There we go. It's a counter. So pretty standard thing in digital electronics. You've probably built one of these things in 2300 lab if you've taken that class. And just by default, if you haven't, this is your first time learning electronics, we'll go over like just a small amount of theory that we've covered from the previous lectures of the Soldering Workshop. Actually, we covered a bunch of the topics to build this exact PCB in the Circuit Analysis Workshop. And we'll review some of that. We'll teach you guys how to solder, go over some safety regulations you must know before going into the room. And Sam will help me here in case I've missed anything, because I definitely will. Okay, so for those of you guys who have seen this before, this is the exact same presentation. I've just like reformatted it. And I really apologize for the delay. We're starting about 15 minutes late, but this will take about, I would say, 45 minutes to an hour. And you guys must know a few things about soldering before you go actually into the lab. So this first one is just to prime you guys for soldering. And I don't have a slide for this, but I usually go over like why we do things and why you're here to learn things. And so we'll just bring the question up, why do we solder in the first place? So if you have something like a PCB, right, and you're moving on from breadboards, let's say you make your breadboard prototype with the jumper wires and the components, you've succeeded in making a circuit, you order a PCB, and now you're at this stage where you have to start soldering things to PCBs. Well, soldering is the act of just melting metal, usually something like tin, iron, lead, and if you use non-leaded, then that's another story. So there are different types of solder. Again, we'll talk about that a little bit later, but the general types are like leaded and non-leaded if you're talking about the wire. If you're talking about the paste and you're doing something like SMD soldering and like reworking, that's something else. So generally there are, like I would say 3 types of soldering. There's through-hole soldering, there's SMD soldering, and there's wire soldering, in which we like just wire solder something together. If you want to be like a hardcore electrician in the future, you are probably going to be doing something like this, and you're going to have to learn something called the engineer's knot, which is a lot of fun to actually use. So I actually prepared, like a short little introduction to soldering physically in my own lab room. Unfortunately, I didn't get it all done, so I'm just going to show you guys the first part of it. No. So we're going to watch this video, and then I have one on THT soldering. You guys will actually be doing SMD soldering today, which is, ooh, spooky, scary, fun. It's very big, though. The component is the AMS117, and it's the voltage regulator. So it's a very big chip, but it's a good way of segueing you into SMD soldering, if you guys don't know what that is yet. So let's take a look at this. This is my soldering station. It's got a lot of different parts to it, including, your soldering iron, your hot air gun, your little metal sponge used to clean off the tip, your Koto box fan for the exhaust, some soldering wire. I think this is 6040 lead tin. We have some tip tinner here, some flux, some solder wick for, desoldering, some extra wire here, and some pliers and wire cutters, and also some random components lying about. This is generally what a regular soldering setup looks like. I have been soldering for about 2-3 years now, so most of this stuff was built up over the years. But if you're very new to soldering, let me go ahead and tell you exactly how to actually prep your station before you solder some component or another. Generally, all you need to start soldering is just a soldering iron, like this one, and some solder lead or solder wire. Now, this is lead solder wire, and I know like many intro kits provide you with lead-free solder wire. Lead-free solder wire is not, I'm not a big fan of it due to the fact that it doesn't flow well. You need a large amount of heat in order to melt it onto the board, and it's a large potential for cold joints, which means that your solder joints might fall off eventually. So I use lead solder, and that's for that reason. When you turn on your soldering iron, and I use the temperature about 480 degrees just because I want to do this fast and quick. That's not really recommended usually for soldering. You want to do this at around 380 or to 400 degrees of temperature. I just use 480 because it's quicker. And I have to solder a lot of stuff at the same time. So before you solder, what you want to do is you want to do what's called tinning your soldering iron. You want to make sure that there's a very shiny tip at the top of the iron, such that when you solder your connections, it'll be very conductive and the solder will just flow right onto your board. Now, a lot of times when you just start soldering after like a long period of not soldering, your solder tip will be like a little bronze color, and it might be dry, and it'll just need a little bit of solder. So what I like to do is I want to turn on my Kodo fan, and it's going to be very loud because this is an exhaust fan, and I'll just apply some of the solder directly onto the soldering iron. And I'm going to rotate it so that I get an even coating of solder on all different layers. And you can see how the exhaust fan is basically inhaling the smoke that I don't want to be inhaling myself. So I can see my tip is now coated with a good amount of solder. I'm going to use my metal sponge, and I'm going to go ahead and brush the sponge in this kind of motion. I'm pressing the tip against the sponge so that the metal sponge can evenly coat my soldering iron with the metal that I just put on it. So we can see here, after just a few strokes, I have given my tip a little more metal than before. Now, you don't want to do this too much, otherwise all the metal will fall off. So usually I just like to plunge it in, give it a few strokes, and then out it comes nice and shiny, and you're ready for soldering. Now, once you finish soldering, what you want to do is you want to go ahead and put a big blob of solder onto your soldering iron. Probably should have turned this back on. Just so that the next time you solder, it'll kind of already have the metal on it in order for it to not dry out. And so with this case, you can go ahead and turn off your soldering iron and just put it back inside the holder like this. And then it'll be ready for the next time you solder. So that's how you prep your station for soldering. That was just an intro on how to set up your soldering station for actual soldering. When you get to the lab, this will be kind of like what you have to do in order to get your station ready. If you are going to be in, there's 2 lab rooms we have due to the amount of students we have soldering today. So if you're in room, I think it's 435, you guys have brand new soldering irons, which is awesome because they're brand new, which means they have never been touched before, which means the tip is, at its best quality. You get to tin it, yes. So you will have to tin it if it's a brand new soldering iron, and if it's not a brand new soldering iron, you'll probably still have to tin it because no one's used those things in a long time. So yeah. So that's, for tinning purposes. So based on this slide, we'll go over the 3 types of soldering. Through-hole soldering is like if you're soldering a resistor. So through-hole is like if the component goes all the way through the board. SMD stands for surface mount device. Again, you guys will be soldering a surface mount device onto the PCB, which is the voltage regulator. And the third one is wire soldering for like hardcore electricians. Soldering iron, okay. The way I formatted these slides is there's like not many words on here. I just put links because I'm going to share this with you guys, and if you want to like set up your own soldering station for the first time, you've never soldered before, these links would be probably the good ones to go for. Now, it's funny because I put like 2 versions of it. This is like one that everyone gets like on their first rodeo, and it's fine. The soldering iron is okay. I would just recommend against using this type of solder because the ones they give you inside the elementary kits are like really bad. And the first time I soldered, I was using like this kind of kit, and I was trying to solder like an IMU together, which is like a small PCB for like a robot, and it just didn't work. It was just really bad. So I bought the solder I have now, which is the 6040 lead tin solder with a flux core in the middle, and it was so much better. So you can use like soldering wire like this as long as you have good solder. That's the moral of the story. Now, if you want to ball out and if you're more experienced in soldering, you can get like one of these soldering stations. The one I have has both the soldering iron and also the hot air gun for SMD reworking. And so these ones are like about $50, $60. I don't know if like inflation has caused it to go up since the last time I presented this. But if you want to do some serious soldering and you're going to do this over and over again, use something like this on the right. Yeah, we can talk about that a little bit. So for like SMD, the reason why we use SMD components is to reduce the footprint of your part that actually goes on the PCB. So if you want to make way smaller PCBs, and smaller PCBs are generally a good thing, you would go ahead and use SMD components when you design your PCB. However, that does also require you to do some like more intricate soldering because sometimes these parts are like really, really, really tiny.
Some of them don't even have like exposed pins. Like there are some packages out there, like for some of these kinds of components that have what's called solder ball, meaning that it's literally little solder pads that sit under the chip. So there's no leads coming out of it, and they do that for a lot of different reasons. Actually, the biggest reason they do it is for security. So you don't have like people like me who are trying to read the data coming out of those chips to try to spoof it or bimp it or do all sorts of things like that. Yeah, if there's exposed pins, I can fuzz into them and basically scrutinize traffic, but with a solder ball, it's a lot harder, a lot harder. So
there's like different levels of soldering. What you just talked about is like at the very top of like how hard it gets. For the most part, like if you get to that sort of like level, you're gonna have like robots doing the soldering for you. Yeah. Like pick and place robots, it's gonna do automatic, and you're just gonna get this assembled PCB. That's called PCBA if you're going to order it on like some websites, PCB assembly. So I've been on the side for a while. Let's talk about this. This is what I use, which is lead solder. Now, a lot of places don't like using lead solder because it's lead. You don't want to poison yourself. Oh, yeah. So, but it's really great compared to lead-free solder. So let's talk about this a little bit. Why do I like lead solder better than lead-free solder? Now, if you get good quality lead-free solder, that's great to use. Like you can use it all you want. Just know that it's a lot harder to like manage because it has a higher melting temperature, right? Yeah. So it has a higher melting temperature, and with that, if you don't crank your soldering iron hot enough, it'll form a cold joint. And that's no good because cold joints will fall off after a while and become like not conductive anymore. Yeah, so the primary goal of soldering is to make sure your connections last basically forever and can stand within like weather, extreme heat, extreme cold, someone like throwing your PCB against the wall, it has to stick, right? Something like that.
The other thing that's kind of nice about lead is that
lead forms a oxide layer, really similar to how aluminum oxide works. And so that lead oxide can protect itself against a lot of different things. Like lead doesn't really rust because it's not iron based. And on top of that, it's kind of has like this sun protection effect as well, which is kind of like what comes with it. Most people don't really realize that because lead is not really found in like a lot of different things nowadays. But if you find like older stuff, like especially like lead bearings and stuff like that, those actually were pretty good because you can run them into the ground and they were actually like pretty decent stuff. It's just that people started to figure out how dangerous lead was, right? So we don't really use that.
They're also starting to phase out like leaded solder in like about 10 years or so. So in the future, we're not going to have like a silky smooth connection like this, but they're starting to come up with like better alternatives. Yeah, like lead-free solder, but they still have like the flux rosin core, which we'll talk about. So that's also like amazing to have. So I use the 6040 tin lead, that's the first part. Flux core is the next part. So flux core just means that in the middle of this solder wire, we have basically a cylinder of flux. Now what flux is this like nice little paste, nice little liquid that helps you oxidize your connections, basically remove all the air bubbles inside of it and makes it a really nice and smooth metal connection. So you need flux to solder. And I don't use flux to solder often because I have this kind of stuff. The flux is already inside. And so if you don't have this, it's what some of my friends actually use. They just use like a solid core without anything else. They have to apply flux to the board before, before like soldering. And it's true if you use like packages like those, like an ATmega 328P, if you're like the little chip on the Arduino, if you're like soldering those square pads down, most likely you're not going to use like this kind of solder to do it. You're going to use solder paste. So you have to apply flux.
Sometimes the flux comes with some paste too.
Yeah,
Kind of cool.
that's
Like,
true.
the newer stuff is like that, yeah.
Yeah, they're coming up with more and more easier ways for consumers like us to actually solder stuff together.
Are we consumers? Or are we
Consumers, hobbyists.
Obvious.
So exactly how do you protect yourself? Now you can protect yourself from this stuff in a couple of different ways. Part A is, let's talk about this for a second before I go to part A. So when you solder using this stuff, it creates fumes, right? Now the fumes aren't what really kills you because the fumes are from burning the flux. You're smelling like the flux fumes, which is an irritant, right? So if you smell those fumes in, you're gonna get like a clogged nose, clogged ears, clogged lungs, clogged holes. It's really irritating, but that's not what kills you. Now here's what many people don't actually realize until they get further into soldering. It's actually touching this stuff. Because when you touch this lead, it gets into your fingers, right? And yeah, basically your skin eats it up like butter or like any sort of good food, like butter. But you want to avoid touching this, which is why when you see my demonstration video, I'll go ahead and use pliers to touch this stuff instead. Now, if you touch this for like 10 minutes or so and you go immediately to wash your hands, then it won't hurt you. You're completely fine against that. But you want to be careful. And not like, I know some people who like do soldering for the first time and they go ahead and like just wrap the solder around their hand like a bunch of times. And it's kind of like, I'm just like, do you know what you're doing? Because your skin eats it up. So if you use lead solder, make sure you wash your hands. Chase.
Do you recommend gloves?
You can use gloves. So I use gloves for solder paste, and that's kind of a must because solder paste is little beads of solder that kind of like forms like paste, like red bean paste or Nutella kind of consistency. But
It's an irritant. Right?
Yeah.
So, yeah, you don't want it. It's like little crystalline structures inside that.
So you definitely you want to wear gloves when you're working with the paste. Flux, you're okay. Actually, I take care of bees, and believe it or not, we use beeswax as a flux. It works. It actually works like really well. It's a cool byproduct. But for the most part, with the lead-based solder and everything like that, nah, you should be fine. I mean, I can't say for sure if like, you know, whatever, how much lead you have taken in versus how much lead I've taken in kind of thing. But like, I've probably taken in a lot more, honestly. But like, the thing is that, no, you're okay. I mean, it comes down to like fidelity, right? Because if you put a latex glove on and you're working with like an iron and you burn the latex glove, that's really bad. Because now you got like burning latex like on your hand. And you don't want that. And those big like worksman's gloves too that have leather, none of those have good fit. Yeah, exactly. So whatever. You value your safety over fidelity, whatever. It's like one of those things, right? If you leave it on there for more than a couple hours, it's okay. Just don't like go to sleep after you play solder. like just wash your hands.
the bottom line is make sure you wash your hands after this workshop, please. Don't go to Pizza Hut and eat pizza with your hands.
Don't bite your nails. Don't
Yeah, wash your hands,
Yeah.
please. Like, even if you like,
We get a call from somebody. It's like, yeah, my son got lead poisoning. I'm like, what did he eat? What did he eat? The core?
yeah.
Chowing on it.
So I recommend everyone to wear a mask while you solder, not just because of COVID, but because you don't want to go home and like have allergies for like the next couple of days because you inhale fumes. And the mask helps protect against that slightly. So bottom line is, again, to keep yourself safe and to keep us safe, wear a mask. You don't have to wear gloves, to make sure you wash your hands rigorously.
Or so.
Soap and water, like I just like scrub it off, because what happens is that if you actually touch the lead with your fingers, it goes on like the top layer of your skin, and then the more you wait, it just goes deeper and deeper and deeper. So you're kind of like scraping those skin cells off. And then if you want to be like really like picky about it, if you're like a germaphobe, you can use pliers. I think we have enough pliers to supply every station with one. So if you want to use pliers instead of your hands, you can. Don't let it scare you away, because hands is safe. Like you can do that. And also, I want to talk about a point that Sam said. Basically, for gloves, the reason that I don't use gloves for like just this kind of soldering is because you don't get precision in like putting stuff down. Yeah. So
I don't use them because that is increasing my chances.
Yeah. All right, let's take a look at this video, which explains good solder joints and bad solder joints. Actually, different types of quality of solder lead.
Did you record that?
No,
I'm shy.
no. So at 300 degrees Celsius, it's not even melting. That's not hard. You can see the particulates inside of it, like the air bubbles and everything. Like it's got inside. It's not melting. What side is that? A lot better than this little thing. That's fine. This is cool, so that's like
It's like crystal.
All right, I'm gonna stop it there because we don't have time. But basically, when you solder, I always say this, but you want a Hershey's Kiss shape. Basically, when I show you the video demonstration of the Blinky Learner later, you'll see what I mean. But you want to make your solder joints look like Hershey's Kiss shape. You don't want it too low or too high, like it's a hemisphere. That way, you won't have. Well, if it's too low, you're gonna have stuff falling off because there's not enough solder. If you have too much, that's also a bad thing. A big bubble of solder, you're not gonna have like enough like connection. It's not gonna be strong enough between the PCB and your components.
There's really no way to avoid that besides just practice.
Yeah.
You just don't really know how much you do, which is why this exists.
You have, yeah, you develop a muscle memory. So I can show you some, because like a portion of this is actually designed for speed soldering. So if you're like really good at soldering, you can solder these like 5 chips really, really fast. And I can show you like how that looks like. Okay, this is what I call stupidly expensive fan, but it actually works. This is a Kato fan. Its price is like so variable over the past like few weeks or a few months or few anything. It was like $30 the last time I saw it. Now it's like $50, and like it's great piece of technology used to suck all the fumes out, but it's expensive. Solder fumes can be dangerous just because it's an irritant. It's not gonna kill you, but it's also not recommended you like just breathe a lot of it in. Yeah, if you're soldering indoors, make sure your ventilation is available. Now here's the thing. We're gonna be a bunch of 40, 50, 60 students soldering inside 2 lab rooms. It's not gonna have, the ventilation is not gonna be great. Let me just tell you that. And we don't have these fans to help us either. So, yeah. Be safe and wear a mask in this situation.
You can 3D print those too. There's a lot of like
Yeah.
solder.
Yeah.
There's like these little ones that like Adafruit made.
Yeah.
It's English well. If you have a high like CFM fan taking stuff in like that, it's pretty fun. Because for the most part, if you have like a bigger surface area, it's better because you have to change the filters less. These are just carbon filters. You can buy these for like by sheets.
Like
you just kind of
$2 each, something like that. So if you want to build your own, you can. The inside of this is basically just a computer fan pointed backwards. And they overpriced this. Tip tinner. Okay, here's a thing that I learned just like last year, because I was doing this on stream, and then my stream audience was like, you shouldn't be doing that. Okay, it says here you should, it doesn't say here, but you should try to tin your soldering iron every single time you solder, just to make sure it's shiny, but you shouldn't use this stuff every single time. You only use this stuff to basically revive your tip, right? Because this stuff is kind of like volatile in a sense, where Yeah. So it's like putting bleach on your soldering iron in a sense.
Plus, if you're balling and you can afford that stuff every time, because that stuff's kind of expensive. So.
It's like $5 per tin. So
That's a lot.
it's for reviving old tins, but we got one for everyone. So
Oh wow.
yeah.
So we are balling.
Yeah. I had to pull some strings to get all our equipment today. So conductivity matters. Again, your whole goal of soldering is just to make sure like the solder joints on this thing stays like this forever, even in harsh climates, even if I like crush it with a sledgehammer. Yeah, yeah. So that's how you get long lasting joints. Solder sponges. Okay, so we have. Don't use wet sponge. Like I saw them set up wet sponges, and I was like, I don't know if we have enough metal sponges here or not, but these are like amazing.
It's okay. Wait your turn. Don't use the. Please don't use them.
The reason behind these is because your soldering iron will react to the metal that is on these sponges and use it to smooth out the tip. You're gonna get really shiny tips if you use this thing. Not so much with sponges. Sponges you can use to clean off excess solder, but really like this will do the same thing.
Right, but like the problem is that you have a burning iron-based tip, and you're literally suspending that to water, right? And heat is a catalyst for iron oxide, so it's going to rust faster, exponentially faster, if you are using like a wet sponge. Do not use them, right? Like that, like unless you want to like buy new tips and you're again a baller, right? But like it's not worth it. Like I did that for so many years, and I went through so many tips until Amazon blessed me with this beautiful image of these lead sponges, and then I literally like understood that that's realistically what you should use. 100%. Like,
Yeah.
no exceptions.
You learn this from experience. Like what Sam said, I also went through like 6, 7, 10 tips before I was like, I should have used this in the first place.
Yeah, instead of spending like $50 on new tips. Yeah.
So if you guys have the new soldering iron that comes in the box, you guys will have like a little piece of sponge. Do not use that, please. You're gonna kill your iron.
You can use that to clean your plates.
Yeah. All right, we gotta hurry up a bit. Okay, so applying flux. Now this is what flux looks like. Here is a pen version of it. Here is a little paste version of it. We have also flux syringes and liquid flux for you guys to use in the lab. If you guys don't have flux core solder, please use this, or else you'll get cold joints. And definitely, like there'll be helpers walking around and checking your joints for you. Sam's one of them. I'm one of them. If you see anyone else with a name tag, and they have like direct contact with me, basically they can just like yell us down at any point, and we can come look at your stuff for you.
I'm kind of picky.
I'm also kind of picky, so
So maybe not me or Chris, but somebody else.
I think we're the only ones doing it. Okay, desoldering tools. Oh. This is the Gucci version of a desoldering tool.
No. You got to show them the SSO2.
Oh.
SSO2. Japanese SSO2 solder sucker is by far the best one. There is like a culture surrounding that solder sucker because of how good it is, right? I mean, I have like 3 of them, and they're so good. Like I never had one break.
Yeah.
Yeah, they're so awesome. Anyway, yeah, those are awesome.
Yeah. So there are 2 methods of desoldering. One is using these solder suckers. One is using the solder wick. Sam was making fun of me using solder wick, but this is kind of like a sometime situation where you actually have to use this to clear up solder. And it's usually used for things like desoldering rows of header pins. Now here's the thing about rows of header pins. They're almost impossible to desolder once you've like soldered all the pins in, unless you're like you just yank the whole thing out and just like individually start pulling things out.
You have the potential of ripping off pads.
Yeah. Yeah, so like for the most part, like if you guys do some projects in your future using an Arduino and a PCB, do not solder the Arduino directly to the PCB. I've seen that happen before. Do not do that unless you're like 100% certain the PCB works.
Or you're designing the PCB to have an Arduino on it. Like you're literally taking the chip from the Arduino and putting it on there. Yeah. But at that point, it's Arduino.
Yeah. So like rows of header pins, I'll go over a technique to solder them because you do have to do a few of them on the board. Basically, the technique is solder the first pin and the last pin, make sure it's straight, and then solder the rest in, right? But like, don't solder it directly. Like we gave you the, with these IC chips, we gave you these sockets for a reason. Use them. Don't solder it directly. The dips, the dual inline packages. Helping hands, we have some for you guys. You technically don't need helping hands for this one, but I don't like helping hands. They never work for me. They're supposed to hold your PCB in place for you to like solder. I never use these either. But if you want them to like just have around in your soldering station, you can. They're like really flimsy though. Like this kind of thing, like the base just falls off all the time. It doesn't stick.
What sucks about those two is that the tensions on those pinchers are almost too much. They usually scratch the board. Yeah. So people take like what's it called, heat shrink, put them on the tips there. Yeah.
They are good for one thing though, which is connecting wire. So if you want to like wire like a motor to another place, these are like amazing. So that's what I sometimes use it for. Like, but it's like a one-time thing. Yeah. I just like call someone over to hold the wires for me. All right. Really fast slide about heat shrinking. Basically, you have some kind of plastic, you blow it with a heat gun, it shrinks around whatever you're doing. Really good for like if you're doing soldering motors so that you don't have any open connections, because open connections just scream, a charge is gonna jump from one end to another and create a short and pew, boom, your circuit explodes. Yeah. So that's what heat shrinks are used for. Here are the links if you wanna get them. They're not affiliate or anything. Yeah. Okay, soldering safety, very important. That's what we're here for. How much time do we have? 12 minutes, okay. Last time this went at like an hour and 30 minutes, so we're good on time-ish. This is what you guys have to like listen to, and we have to tell you guys this so we don't get in trouble and you guys don't also get in trouble. I remember the last time we held this soldering workshop, no one got hurt except for me. So that's a good thing, I think. Soldering safety, very important things, all right? Here we go. Wear appropriate attire. I sent out an announcement at the beginning of the week saying make sure you like dress nicely. If you have long hair, make sure you tie it back so it doesn't get burnt. You know, like wear closed-toed shoes, that kind of thing. Soldering isn't a dangerous task. Like when I do it at home, I don't like wear like a hazmat suit, right? But you still have to like make sure you wear something appropriate so you don't hurt yourself. So tie hair back, no open-toed shoes. Watch out for solder splash. Okay, this is fun because if you're using solder that is like volatile and may like when you're heating it up, it will pop at you sometimes.
Your iron is too hot.
Yeah. Yeah. So sometimes, you know, something happens, a chemical reaction happens, and a little bit of solder just jumps right at you. And it hurts. I'm not gonna lie to you guys, it's just for like an instant, it's kind of like getting a shot, but like 480 degrees Celsius iron hitting your skin at like Mach 1. Oh yeah, true. That's true, yeah.
Would it be compared to, let's say, if you're boiling oil, like
No. No, it's not as bad as that.
It's not the same. Like I'd say, like if you're like boiling oil and you throw something in,
yeah,
it's like, but a lot less. Like, cause like.
I mean, no, definitely not.
No. Just, guys, if the iron is too hot, it's sputtering.
Yeah.
Just get it to a right temp, it won't be rocks.
And also the thing about this is you want to like push the solder in at a very steady speed, not just like all at once.
Especially rosin core.
Yeah, because like that's where the flux is, and that's where the flux will jump out at you. Always assume the solder iron is hot. This is an extremely important point, okay? Even if it's turned off, always assume it's hot. Never like grab it by the handle. Always assume it's hot. Always assume it's, I'm gonna say it one more time. Always assume it's hot, right? Because like even when it's unplugged, the residual heat can burn you if someone just grabs it by the handle and just goes, oh, let me go ahead and see what's going on. Yeah. I even put it the second time in big caps. If there's anything you should remember from this lecture is that assume your iron is hot at all times. Okay. Now what's wrong with this picture?
That was the image I was thinking about, yeah. What's wrong with that? She's moving. And if it was a higher image, like a higher fidelity image, she's actually holding it like right over the plastic, like the PC, like the PCIe card slot. So it's like she'll just melt that.
Yeah.
It'll just go like right through it. Yeah.
Don't do this, please.
If that was a dead motherboard, it's certainly going to be more dead.
Yeah.
She's done with it.
Yeah.
So.
So
Chase?
you were saying we shouldn't pick it up by the handle when it's on?
The iron, metal iron.
Never touch this front part, basically. Just don't touch it.
Making sure.
Yeah, don't touch it. Hold it by where you're supposed to hold it, like the rubber handle.
Usually the handle's right here.
Yeah.
It's typically, if you're not cheap, it's typically a different color. right? So like the part where you're supposed to grab it, it's like a little. It's kind of like like people like kind of get all worked up about like tennis rackets and like how they like grab those things. It's like the same thing. It's like a little heat shrink that kind of.
It's pretty obvious where it is.
Yeah.
All right, there's a second slide to this, and this guy is actually kind of holding it like kind of right, but like at the same time. Yeah, that's kind of scary.
That's a man who doesn't fear.
Like he's holding it right, but at the same time, like that's really close to hitting you.
You're gonna feel the heat.
Yeah. So that is something I want to talk about with you guys actually. Even if you like hold something really close to it, like the heat will go outwards, it'll radiate from where the iron is. I've burned myself before by just like putting my finger over here. So like,
Do I really look like I'm not soldering?
yeah, like you'll get internal burns, which is like an even worse kind of burn. You like feel it. It doesn't feel right, basically.
I'm gonna give you mental burns. Like, I'm gonna roast you. That's terrible.
All right, yeah. So always place the iron back in the holder before doing anything else. Allow for some slack in the power cord. Like don't do this while you're soldering, because if someone trips over this wire and you have a soldering iron in your hand, this is gonna go like flying across the room. And nothing's scarier than a 480 degrees Celsius flying iron.
Can't say I've ever been in that situation. That's pretty terrible.
Yep. If you're not using the soldering iron, you have to go to the restroom or something. Make sure you turn it off.
Yes.
If you leave things unattended, they may catch fire.
I have done that. I have left it on. I've left it on for a long time, and that was really bad. I had to throw that entire iron out. Yeah. That was really sad.
Yeah. Also, the longer you leave the iron out, the more it'll like rust and dry out and like just.
Exactly. No, it destroyed the whole thing.
Yeah.
Huh?
Oh
That's-
no.
yeah.
No.
You and I had the same. Did your parents get mad at you? Mine got pissed. They were like,
No.
okay.
Can't you just change the heating element, like inside?
Well, no. So what happened was that it got so hot in the chamber, the thing that holds the holder melted.
Okay.
Yeah.
I did the
It
same
was a
thing and
hot
it didn't.
plastic mess. Yeah.
All right. Next point. Ventilate the area. Again, if we don't have ventilation, just use a mask. Okay, so last semester we had a Blinky Learner special, which is basically last semester I put too small of a resistance inside the kit, and the LEDs basically would blind you if you look at it for too long. So this time that doesn't exist, right? You're fine with this. Yeah, and it was 9 volts, and it was a super bright LED. So yeah, so don't stare into LEDs. You don't have to do it for this one. You can stare directly at it and it'll be fine, because I actually like built the PCB right this time, so you'll be okay.
The class that him and I met each other in, he actually, like, we were building LED circuits and I used 330 ohms. And I remember it was him, basically the entire Twitch server that he was using. We're all just like, what are you doing? Like you're gonna completely like destroy those LEDs. And I'm just like sitting there like, so that was pretty funny.
All right, we've gotten to the portion where we talk about Blinky Learner 2. This is the second version of the kit. It's completely different this time. We had it specially designed and commissioned for this exact workshop.
So it's exclusive.
Yes, it is exclusive. You won't find it anywhere else until after this workshop, in which you can then buy more. Okay, so let's go ahead and identify some main key circuits in this schematic. And for those of you who have attended a previous workshop of Hyperloops, we have about the same, we have a few notable circuits that are in here, right, from the circuit analysis and circuit construction workshop. So basically what we have here is right on top left corner, this is our good old friend, the voltage regulator, right? Yes? No. Yeah, I don't think I'm gonna try to do that right now. Sorry. Just trust me, that's a voltage regulator
If you
circuit.
search up buck voltage regulator,
I'm sure it's great.
Yeah. So this is a ripple counter, basically. Here's the counter logic. Here's the LEDs that wire up the outputs to where the LED circuit is. Over here on the top here is a multi-vibrator 555 timer circuit. This is what creates your clock. This part. It's where you have that capacitor being a timing capacitor. Just yeah. That capacitor, by the way, is extremely important. If you change the value of that capacitance, it'll change the speed of oscillation. Yeah. So is this resistor value. This potentiometer down here.
you know what that circuit is? We call that a reverse avalanche circuit. So that's an oscillator build. they use those for synthesizers like all the time.
Oh.
Like unironically, like that's actually a really common circuit. I just realized that. I was like, what is that? Yeah, that's cool.
Yeah.
That's
So that's in your circuit. That's the little 8-pin chip you have. This is the decoder, basically turning these binary signals into the 7-segment display. So you're actually going to be able to see both the 7-segment display and the binary output on your PCB.
if you're an electrical engineer, you're gonna
Yeah. You have them for you right here, just like, that's it. So down here we have a reset circuit. Basically, if it reaches 9, we're going to clamp it back down to 0. And here we have a reset button that's just using a pull-down resistor to ground. Now, can anyone tell me why this circuit on the top left here is so important? Why do we have to regulate the voltage down to 5 volts? Chase?
Because the components specifically one on 5 volts, like the NAND gates. Assuming those are NAND gates.
That is, these are NAND gates actually. So
What are you using to power though? What do you guys think?
9-volt battery.
Yeah.
So they did regulate the.
yeah, so if you power the IC chip with a 9-volt battery, it's not going to like you. I think it's probably going to run, but it's not going to like you. It's going to heat up, and you're going to have hot chip. Okay, that's all I have to say about this one. So from the PCB design workshop, we learned how to turn this circuit. I prototyped it on a breadboard, and now, boom, it's a PCB. So that's the PCB you guys have. It has some questionable routing, I would say, because I kind of rushed it.
That's a lot better than what
So the most important thing to note here is to understand how much current is flowing through your design before you design a PCB. Now, the maximum current flowing through this is probably around 0.5 amps, I would say, mainly because of the 7-segment display. Yeah, because I put 330 ohm resistors here because you guys need practice, and I put 7 of them. Theoretically, you only need 1 connected to the output of the common anode 7-segment display. So yeah, basically you're gonna have the same current traveling through all these resistors, and it's gonna run at about 0.5 amps. Now the trace width of this PCB is 0.15 mils, I believe. Or no, it's 15 mil, which means that the maximum amount of current it can handle is about 1.2 amps. So you're fine, it won't explode. And the rest of this, this right here is called a via or a via. Basically, it's a small little hole that goes through your PCB. There's so many wires on this PCB that I couldn't fit it all on like 2 layers, so I have to do some like sketchy stuff. Sketchy stuff there. And this is what it looks like with a 3D view. So that's what you're gonna be building today. Basically, if you wanna pass this around and just play with it for a second, just know what you're going for. Okay? And then I'm going to show some clips of the construction of this, just to make sure you guys know exactly what's going on and how to solder the kit together. I'm not going to show this whole video, I'm just going to jump into important. I hope this is processed on YouTube by this time. I just did this video 2 hours ago, or 3 hours ago, or whatever the hours ago was. Okay. So hopefully if this video is uploaded, you'll get a step-by-step guide on exactly how to build this. It took me like about 49 minutes to build this entire thing. Double that, you guys have 2 hours. I'm not sure if you guys will be able to finish today, but you guys are free to take this kit home. It's yours. And if you want to get a soldering station or just use the ones we have here at Cal Poly, you can definitely do so. So pretty much what I'm doing here is placing the resistors inside their designated slots. And the actual resistor length actually had to get changed a bunch of times. You see here on the back how this technique basically locks the resistors in place so that you don't have to use helping hands. You can just solder directly on the board. And so basically this is what that is. And you can skip through the video, some more. It's just the same thing. And that's even more of the same thing. Okay, here's where I turn the soldering iron on and begin to solder this PCB together. I just said that, but yeah.
Okay.
So basically you're bending the leads and clamping them down to the bottom of the board so that the resistor doesn't move, so they can solder them well.
Whenever possible, try.
Yeah. Okay, the little push. A little more solder on that. Okay, you can see me here just putting a little bit of solder. I'm doing this quite fast because I already have that muscle memory of how much I need to. Yeah, these are needle nose pliers. I don't want to touch with my hands, and I just grab it. This is really fast speed, by the way. It's like 80 speed. So let's take a moment to analyze exactly like how well my solder joints work. This one is fine. It's a little bit bulbous and a little bit of a rounded edge. You kind of don't want that, but since it's a little like small tiny pad, it's probably fine. This one is good. Actually, this is a good solder joint. This is a good one. This is a good one. This is a bad one.
Yeah.
This is a. It's okay.
Under.
Yeah. It's okay.
A little over. Yeah.
A little under. This is under. Too over.
That's good. I like that. Well, I guess yeah.
Yeah, this one's a little over just so you can see the shiny
Great.
rounded edge.
Fantastic.
Yeah, this is what you want.
Yeah, that's awesome. Those three, those are great.
Yeah, so you want kind of a Hershey's Kiss shape, and kind of like not too much, not too little kind of thing.
Yeah.
Like Goldilocks and the Three Bears, but for soldering. And then this one's okay, but too much. This one's too little. Again, I'm rushing on this kind of stuff, so you'll see me like mess up a little, but you just generally, if you get around the same area and you don't put like the entire reel of solder wire onto the one pin, you'll be fine.
It'll work.
Yeah. Listen to you. Okay, so what I'm doing here next is basically just cutting them. I'm really blocking the camera because I have no sense of where the camera's pointing at. Basically, we're gonna have to like snip this. And each of you guys have a wire cutter at your station, so you guys can do this as well. Basically replicated my own station into like 30 different variations for you. Okay. Okay.
Oh yeah, hang on.
Oh,
Yeah.
this is good. Okay, you guys need to know how to do this.
So, does anybody know what that is? Right there. What do you think that tape is used for? Pick and place. Sorry. You said that? Yeah, exactly. It's for a pick and place machine. Because typically how the pick and place machines work is they work on a reel system. So there's a separator that basically removes that plastic shield. The machine has a little suction and it goes through and it literally like fix it, places it.
So here's the cool thing about soldering this SMD component with the soldering iron. It kind of like magnetically like locks into place, which is like the most satisfying thing ever. So I'm very excited to see how you do this. So the way you solder SMD with soldering iron is literally you just look at it and move into place. What do you mean?
Bro, you just like
Yeah, but look at this, look at this. Like, it moves it. You solder the tab together.
I do mine a little bit more. So I put a little bit of solder on the pad first, and then I place it on the That's it. Really scary. I mean, it's cool. It works, right? But like, you know,
For smaller parts, I'll do what Sam does. But like for this big part,
I'm just a. Yeah, that's it.
so that's what the SMD component should look like when it's soldered.
Oh,
Nice
okay.
and flat, and get like some nice solder.
Very good. Yeah, very good.
Yeah, I like those ones.
Yeah, that's good.
Right, so take this mental picture and put it in your head because that's what you're gonna have to do in approximately 20 minutes.
Anybody remember what these were called? These little things? What? Sockets, but there's another name. I said it. Oh, one more. Dips.
They're dip sockets.
Dip sockets. Dip switches are, it's the same package, but it needs a switch on it.
Yeah.
So kind of the same thing.
Okay, really important part here. So when you put the dips on the back, make sure you go ahead and solder each of the corners first, just to check if they're like soldered correctly.
What I like to kind of do is I solder one, and as I'm holding my thumb on the other one, I put a little bit of solder on the other, and I apply pressure on this switch.
Yeah. Well, in this case, I just like flipped it over with another PCB because I can see all the
Oh,
all
yeah,
at
yeah.
once. But the important part is you want to do the corners first, because if you like solder incorrectly and it ends up being bent, and you're gonna have a problem. Oh, look at that.
Oh, another thing. When you are soldering a pin and you have your thumb on the pin, like what I was talking about, you're heating up that pin. So it's going to get hot. So if you're holding the thing and it's getting hot, it's going to suck. Yeah, so when you're holding it, try to make sure that however you're holding it, your frustration, I understand. You need to make sure that that part of your skin not touching any part where the contact is actually.
And he actually did that later on with the switch.
I know that sounds really silly to mention, but like I'm serious. That's like where like a majority of my burns.
When you rage, you just forget about. Like,
Yeah, absolutely. Yeah, in your frustration. Yeah, as I say.
Here. Well, that's me breathing because I was like, it's just like.
Never saw your own setup. I just like. And then going
You use masking tape too.
Yeah, that's what I use.
But there's many ways to do this.
Dude, you're fast. That's insane. Oh, okay. So what he just did? Hang on. Yeah, go back. He did something that I should also mention that we did not mention. Okay, in one of these, he lets go of the iron before he pulls away the fuse, and the source gets stuck there. So might it just there it is. There it is. Yeah. See how it gets stuck because he literally pulled away the iron first. So typically, how I usually tell people when I'm teaching this stuff, iron on first, then the solder away. First, when you're running it like 120 degrees hotter, it's a little bit of more of a problem. But like for you guys, if you're running it at it's okay to keep it on there. These components are designed to build this on. No issue there. Yeah, please.
Oh, please don't. That's too long to make.
Well, I mean,
So that's that. I'm not going to show you the rest of this video. I'm hoping it goes to YouTube. If it does, then I'll put it on the Discord.
and if you guys have questions, you can just ask us.
Yeah.
copyrighted music on video or something.
No. It's just like me breathing heavily.
Okay. Well,
Maybe you were humming and that they
Yeah.
picked
it'll
up on
get
that.
processed, but it has to go through like the copyright review and then through high def processing.
That's good.
So it takes like an hour.
Okay. Couple things I want to mention just before you start, because I know you guys are getting antsy. LEDs capacitors are polarized, which means you have to put them in the PCB the right direction.
Right.
Now, lucky for you guys, I actually put it where it's supposed to go right on the PCB for you. Longer leg is positive, shorter leg is negative, right? It's on the side. So there's no like excuse not to see that, right?
If you're unsure, ask.
Yeah, if you're unsure, ask, because once you like solder on there, it's gonna be a fun little time trying to get it removed.
It's okay if you mess up.
Yeah.
It'd be more sad if you soldered it on the wrong
You
way.
should just write it on.
It is written on the board.
Yeah, it is.
Oh, also on the board. Also on the whiteboard.
I just remember that.
But
Long
it's-
lead.
yeah, it's right here.
Long leads plus all the time.
Yeah.
Long lead plus. Always remember that. You'll be fine. You'll be all right.
Okay, and then the last thing was, I think Sam was talking about switches. I want to show you guys where I did the switch. How I just hold it with my hand and like readjust it to be right.
You're kind of a pain.
Yeah. They're not so, these switches aren't supposed to be soldered on the boards. This is a custom footprint I made for it. Yeah, I made a mistake of like, and now I have to kind of like,
I was about to say, do you make that footprint?
yeah. And I kind of adjusted everything. Like that's plastic, so it's fine for me to hold, but like,
Yeah. This is through the frustration rage.
Be very careful with your hands in the office.
yeah.
He is not like a master so
So these ones are like, you have to make sure you put more solder on them because they're thicker.
They're bigger leads.
Yeah.
Bigger pads.
solder on a joint. Think of it as you're fusing two metals together. So
Does
you
that
want
look
to
good?
heat up both sides of the
Is to the
metal,
process.
and then the solder goes on as a
It's
whole.
pressing the HT, but you can see it.
It actually,
SD.
if you do it correctly,
Standard
binds the two
definition.
metals together, not just pouring it on like glue.
Perfect.
SD.
We love it. Well, I mean, everybody's gonna be on their phones, so it doesn't matter anyway.
So here's the thing. I'm gonna go post these guides onto the Hyperloop channel, as well as posting the first 2 videos I recorded for this. I recorded the soldering prep you guys saw, and then I also did a little bit of THT soldering for you as well. So you can go ahead and look at these sources when you're in the lab room. I'll post them on. You can go have fun. If you have any questions, we have me, we have Sam, we have Chris Watson here to help you out. And if you see anyone with a name tag, just go ask them, where's Chris or Sam? Or
I don't have a name tag, but you guys can just.
yeah, so just we're here to help you. We hope you guys have a really fun time soldering.
Good luck,
and
be safe. If you burn yourself, it's okay, don't cry.
go to the restroom, run cold water on your hands, you'll be fine.
Cold water, well, yeah. It's okay. It won't be too tough.
Yeah, but go have fun.